will explain you a method that how to solve a circuit by using a special method. As an example, here I have taken a special circuit containing two cells which are identical and three resistors capital R, and think that these two cells are having same value of electromotive forces. You can see that I have selected them as capital E and also internal resistances simple R, and also you can see that I have selected three resistors parallelly connected across each part LQ, MP and NO. Now think that this ammeter become an ideal ammeter. That means its internal resistance is negligible. Now think that you are having to find the current given by the ammeter. That means you have to find I0. This one is the question for you. Now think what will be the current across this ammeter. You can take the answer in 5 seconds. Do you believe it? Now here I will explain you the method that I am having the answer for I0. Now look at here. These two cells are identical. And also here the value of the resistances connected across these parts become the same. You can see that the same magnitude for the resistance capital R. And also you can see that the electromotive forces of these two cells are directed to the same direction. That means you can see that the electromotive forces are arranged counterclockwise. And since these two parts connected across LQ and NO become identical, and also the electromotive forces are arranged to the same direction, a current doesn't flow across this ammeter. That means my answer is I0 become 0. Do you believe it? If you are not believe it, then I can prove it. Clearly here, when I observe the circuit, directly I am taking I0 as 0. I can do it in 5 seconds. If you are not trusting it, then I will prove that I0 becomes 0. Now here I need Kirchhoff's laws. Here I am applying the first law. Think that this cell distributes a current capital I, and the current I0 flows across this ammeter, and the remaining part, that means I minus I0 current flows across NO. Now first I will apply Kirchhoff's second law for the circuit L, N, O, Q, L. I am taking this enclosed circuit to apply Kirchhoff's second law. That means I am applying sigma E equals sigma IR. First I am applying it for the circuit L, N, O, Q, L. So that think about the electromotive forces across this path. It become E plus E equals, now I am taking the potential differences towards a selected direction. Here a current flows across capital R and simple R here, so that the potential differences arranging from this current I become I into capital R plus simple R, and the other part here you can see that I am having another two resistors, capital R and simple R, and a current I minus I naught flows across these two resistors, so that I am having another electromotive forces, or otherwise potential differences, I minus I naught into R plus simple R. Now here you can see that I am having capital R plus simple R for these two parts, and here I am having again capital I. Now I need to find I naught. Here E plus E become 2E, it become equal to 2I into capital R plus simple R minus I naught into capital R plus simple R. I am taking this one as the first equation for me. Secondly, I am taking the enclosed circuit L, M, P, Q, L. Next time I am applying Kirchhoff's second law for the circuit L, M, P, Q, L. Now here the net electromotive force across this path become capital E equals I into here the two resistors become capital R and simple R for this current capital I. So that capital R plus simple R plus another potential difference, I had to consider it as I naught into R. Now here you can see that I am having 2I here, so that I am multiplying this relation by 2. 2E equals 2I into capital R plus simple R into 2I naught R. This one is 2. So that I am having two simultaneous equations, and simply I can solve them to find I naught. Now look at here, I can equal the first one and the second one. From 1 equals 2, you can see that here if I am taking the first and the second relations, I will write all the terms 2I into R plus simple R minus I naught into capital R plus simple R become equal to 2I into capital R plus simple R plus 2I naught R. Now what are the terms that I can cancel here? You can see that I can cancel these two terms here, and only I am having terms containing I naught. Now here I can take the terms I naught to one side, and here I am applying this negative term to the right side, and so that 2I naught R plus I naught into R plus R become equal to 0. You can see that here from this relation, I can see that I naught become a common term. I naught into 3R plus simple R become equal to 0. Now look at here. 3R plus simple R, these are actually resistors. The summation of these two resistors always become greater than 0. That means this one is not equal to 0. So that here I naught into 3R plus simple R become equal to 0. Since this term doesn't become 0, I naught become equal to 0. This one is the proof. But simply you have to know this technique, that here since the two parts become identical here, and since the electromotive forces are arranged in the same direction, I can make a conclusion in 5 seconds. That one is a current never flows across this ammeter. This one is the simple method to take the answer. Now if you like to write equations, then you can prove it by using this technique. But I think the first method is the finest method to solve the circuit instantly.